All right, so example number 2, we're given a function and we want to adjust it. We want to shift it or rotate it or not rotate, but stretch it, compress it, etc. Please make 2 quick changes here just for the ease of use. On part A and part C, please change both of those to x-axis because we're not going to go left and right much on things. We're going to be shifting it or stretching it or reflecting it on the x and y, over the x-axis. All right, so let's read this one here and see what it says. So we're going to write an equation for each transformation, and this is not a parent function, but in our particular, it's our original function. So we kind of treat this like a parent function. So this is where we're starting. So if we wanted to vertically compress this line by a factor of 1/3, and we wanted to reflect it off the x-axis, what is that going to look like? So we're going to do a compression, and we're going to reflect it. So what we're going to do is start with our original function. So y equals, and I'm going to put it in parentheses, 6x minus 2. So because this is a vertical compression, it's going to happen outside. Vertical happens outside the parentheses, so either multiplication there or adding there. But it's a compression, so it's got to be multiply. So all I do is take the 1/3 and multiply it outside there. Next, we want to do a reflection, and it says in the x-axis. And of course, what does that mean? If this is your x-axis and this is your shape, like this, a triangle, and I reflect it in the x-axis, it flips upside down. So in the x-axis means vertical reflection. It means vertical reflection. So how do we vertically reflect it? All we do is throw a negative in the front, and that's it. So I'm going to simplify this equation by writing it into slope-intercept form, and all we have to do is distribute the negative 1/3 to both terms there. And in doing so, I get this, y equals negative 2x plus 2/3. Where did that come from? Negative 1/3 times 6x is negative 2x. Negative 1/3 times negative 2 is positive 2/3. So I did have to simplify my function. So vertical stretch, so I multiply outside the original function. I'm going to add 5 outside in order to shift it up 5. And now I'm just going to take a moment to distribute and clean this up. So distributing it first will give me this. Y equals 42x minus 14 plus 5. The plus 5 is still there. And now we simplify by combining like terms. And minus 9. So that's my final result. Okay, the next thing you're going to see a skill that you're going to work on your assignment. So in this case, we're going to make a table of values for f of x equals x. So that's what this one is right here. In other words, whatever you put in is what you get out. That's what y equals x means. You put in a 2, out comes a 2. So put in a 0, out comes a 0. Put in a 1, out comes a 1. So this is a linear function right here, just y equals x or f of x equals x. Now we're told, in this case, I'm going to shift the whole thing down 8 units. So we understand that to mean we just subtract x, subtract 8, excuse me. So all we do is take the result, the negative 2, and all we do is subtract 8. That's it. It's a very straightforward situation. So here, subtracting 8 means negative 10. Subtract 8 from there, and we get a negative 9. Subtract 8, and subtract 8. And notice the pattern here is just going up by 1 there, too. Next thing here. What we want to do here is describe, we have a function. This is just an f of x. So it's just this check thing weird. There's nothing special about it. It's just f of x. And f of x has 4 points. This point here, and these ones there. And they're just connected there by lines or segments. So we're going to describe what the transformation is right here. Well, clearly we see, because this is happening outside, it's vertical. And because it's a plus or minus, it's going to be a shift. So it's a vertical, and we're going to shift down 2. Now, you don't have to say the word vertical because the down right there implies it. So I could have simply said shift down or translate down 2. So how graphically am I going to do that? So we already have the f of x graphed here, right there, and I want to graph this there. All you do is take each point, so I'm going to start with this point right here, and all we do is shift it down 2. Since I'm counting by ones, each one of these squares is a 1, so I'm going to count down 2 squares to here. Next, this one graphs down to there. This point graphs down to there. And lastly, this point graphs down to there. And now I'm just going to connect the new dots. That's it. Connect the new dots. So here, here, and here. And what we notice is that it's the exact same shape. I didn't adjust it. I didn't stretch it out. So look, my lines are parallel wherever they are because they're the same. It's the same function. All it is just shifted down a bit. All right, what we want to do is spend a little bit of time doing a transformation of a function. So we have one function here that we want to do a couple things to. So looking at this, we can identify translations, reflections, and vertical stretches and compressions from a given algebraic equation. You can apply transformations to a graph, even when it is not easy to write an equation for the graph. So for this graph at the right, we're just going to call it f of x. Why is f of x? And usually it would be written like that. Okay, so we're going to describe what effect is happening to each one of these. So because this one is a multiplication outside, we know it is a vertical stretch by a factor of 2. Next, because this is outside, we know it's also vertical, and it's going to go up or down, so it's a shift down 2. And this one is happening inside the function. So we are going to do a horizontal shift, and it's going to go left. It's the opposite of what I see, so it's left 4. So now what we're going to do is take each one of these, and we're going to apply the transformation one at a time. All right, so now we're going to draw each new graph by applying the transformation. So number 4 here says I'm going to do a stretch. Notice this is a vertical stretch only. So only the vertical component, that is its height. The height here is at a 3. So what we're going to have to do is stretch that up by 2. So we double it. Instead of being at a 3, it now is up at the 6. Oh, but Swenson, what do we do with this one down here? Well, that one's at a 0. So how do we double a 0? We don't. So 0 is still 0. Next, this guy here is also at a 3, so it's going to shift up to a 6. And I'm sorry, not shift, it's going to scale up. It doubles. This next one here is at the -2, so it's going to scale down to the -4 because I double it down. And lastly, this one's at a 1, so it doubles to go to a 2. So now I have to connect the dots of my function. So here we go, I'll just connect this one up to there. It still flat lines to there. And then it goes all the way down to there. Notice it crosses my old function. And then here again, it looks like it crosses the old function. So the shape is basically the same. Like it still has a basic, goes up, flat, comes down. But notice it's not congruent. It's not the exact same shape. It's not that I just shifted it up and down. I've stretched it up and I've stretched it down. So that's why it's called a stretch. All we do is multiply the horizontal by 2 in this case. 5 is a little bit more straightforward because this one simply says right here, all I do is shift down 1. So all I do is take each dot, each vertex, and shift down 1, and that's it. Now connecting the dots look like this, and yes, this does maintain, it maintains its shape. So the shapes are exactly congruent. There's no change in the shapes. So we call that a rigid transformation because it's just like taking a hard substance and moving it around, as opposed to this one, which is kind of gooey, because this now stretches this way, so it's non-rigid. And this one here we saw is going to be a shift left 4. So all we do is take each point and go left 4. So this one's got to go 1, 2, 3, and 4 to there. This one here is go 1, 2, 3, 4 to there. This guy here, 1, 2, 3, and 4. It's hard to mark, so I'll mark it again. It shifts to there. It just happens to map to itself. Then down here shifts 1, 2, 3, and 4 to there. And lastly, this one, 1, 2, 3, and 4 to there. So I'm going to connect the new dots, going up, flat line to there, and a check mark, kind of like right there. Again, this is a rigid transformation because the shape is exactly the same. We've only moved it left by 4. Now, what we want to do is take all of these and do it all at the same time. We're going to stretch it, and we're going to stretch it and shift it left and down, left and down. So what's the process? Well, it turns out that it's probably easier to break it down a bit. So what I'm going to do is sketch this one here, over here, because I'm just going to stretch it, but then I'm going to shift the stretched unit. So I'm going to stretch it first, and then I'm going to shift this one down like I did there and left. So I'm just going to take a moment real quick to show the stretching. So the stretching here, this maps to there, that maps to there, that maps down to the 4, and that maps to the 1. So here's my stretch. So the yellow is the stretch. Now what I'm going to do, and you don't have to connect these dots. You can if you want, but for now I'm just going to leave it. Now I'm going to go ahead and do both the shifting. It's got to shift down 1 and left 4. So I'm just going to take each yellow point, go down 1, left 4. That's it. So down 1 here, left 1, 2, 3, and 4. So that, this first point maps to here. Now continue. The second point maps down 1, 1, 2, 3, and maps to there. Down 1, 1, 2, 3, and 4 maps to there. This one down 1, 1, 2, 3, and 4 maps to there. And 1, 1, 2, 3, and 4 maps to there. So notice the constellation of the red is exactly the same as the constellation of the yellow. It's just been shifted down and left. So I'm going to go ahead and connect those dots real quick and get our final result. And that's our result for all, however you interpret it, but both the scaling and the shifting occurring.